Well, I noticed that a lot of you were struggling with this regression problem, and so I wanted to make a video with this data so that you would understand exactly how to do regression with the data that we've used in class. I know that the other two videos, one was the coastal star sales data that I showed you how to use simple linear regression, but the multiple regression can kind of be a little bit difficult, and so I want you to really understand what exactly you need to be looking at whenever you're looking at the regression results. And so there's going to be really three key things that we'll focus on here. But the first thing that I really want you to understand is in here we had NA for our active alumni. But you can use your ticket sales to predict the number of active alumni. So you can do forecasting with this, and that's what I'm going to show you how to do. I've already done it with the formula that I have here, but I'm going to show you how to do the exact same thing. So if you don't want to have this NA value here, which of course we would prefer to have that, it's missing data, you could put a 0, but that's probably not that accurate. So what we'll do is we'll forecast backwards, and we'll use the data that we have to do this. So to forecast this variable, we would do the forecast function, and we would select forecast linear. We would select, this is the value of our ticket sales that we're trying to figure out. So at ticket sales of 4,995, what is going to be the output? And our output is going to be the active alumni. So we have ticket sales, that's the X we want to predict. Our known Y's are going to be these active alumni here. And so we select those, and then we select our X's that we know for sure that this is from past data. So now we can successfully predict that. That gives us 2,617 active alumni for 2001. So this is going to be our best predictor because we forecasted using our data to be able to use this. Of course, you could use 0. I had told several of you to use 0 to be able to get the results, but this is the most accurate method because it follows based on the data that we have available to us. So instead of 2617.25, because we can't have 0.25 people, I'm just going to make this 2617, and that gives us a nice round number. So now for us to be able to do this, I had you do 3 separate regressions. One, a simple regression for active alumni relating to ticket sales, another percentage of games won to ticket sales, and then I had you do a multiple regression which included both active alumni and the percentage of games won in relation to ticket sales. So we'll do those right quick, and it's very simple to do this in Excel, and that's why I'm going to make this very easy for you. I'm going to do all the results for us because it'll make life easier. We'll go through that much quicker. So make sure that you select all the values in the column for your Y range, and then we'll also select all the values in our X range. And I've also included the labels. It's really nice to have that there, and it's going to give this to us in an output range, so we can see this in a new worksheet. So I'll go ahead and do that, and we'll go ahead and do the other ones that we have to do as well. So I'll go ahead, and we did our regression with just the percentage of games won. Now we're going to do it with the active alumni, and we'll click OK. All of the things remain the same. And then finally, with this, we will do both our active alumni and the percentage of games won. And it's nice whenever you use the labels because you'll see them in your output. So we will first look at our output in sheet 2, which is the percentage of games won in relation to the amount of sales. And so the things that I want to draw your attention to, of course, we can care about the R squared. That tells us how much the percentage of games won explains the variance in the amount of sales. So it's important, our R-squared value, it ranges from 0 to 1. Of course, we want to have a greater R-square valued if possible. But what I really want you to focus on is this beta value. And so the beta value here, our coefficient is what that is. So a coefficient, that is a beta value. And what we're really looking at is, what does this mean? What does 68.144 tell us? Well, it tells us that if you have a 1 percentage point increase in the percentage of games won, you would have a $68 increase in sales, $68.14. However, whenever we look at this p-value, that means that this relationship, because it's greater than 0.05, that it is non-significant. And so that means that there's a non-significant relationship between the percentage of games won and the amount of sales that were conducted in that season. So that explains this relationship. There's not really much more that you need to look at. Of course, the significance here, that's non-significant as well. So the regression model is non-significant. And so the important things to look at are the significance of f, the coefficient of your x variable, which is the percentage of games won, and the p-value associated with your x variable. So now we'll go on to sheet 4, which is the active alumni, and the active alumni explaining the amount of sales. So whenever we look at this, we first look at the R-squared value is very high in this case. We have a really good R-squared value. It's about 0.63. That is very good because it is close to 1. And so now that we've looked at that, we can see our significance of our f. That is a very small value because it has e in it. So e, if you double click on that, you can see that it's 0.00007. And what that tells us is it's much, much, much smaller than the 0.05 cutoff, which means that this model is significant. So now that we know that our model is significant, we can go and look at our beta value for our x variable. So our x variable, what this tells us is, whenever we have an increase by our active alumni by one person, if we increase the amount of alumni, which of course we would expect to do that on a given year, that one active alumni increase gives us a 92-cent increase in the amount of sales. So you can think of this, okay, if you have 1,000 new alumni in a year, or even 100 new alumni, you are going to increase your amount of sales by $92. So think of it in that terms. And we can also look, our p-value here is significant because it's less than 0.05. So we can say that there is a significant relationship, a significant positive relationship between the number of active alumni and the amount of sales for a given season. So that explains the two simple regression models. Now, looking at the multiple regression model, we can go and we can find some other insights. And this is going to tell us if it's more attributed to the active alumni, if it's more attributed to the percentage of games won, and we can see our R-squared value. So first we look at this, our R-squared value is very high here. It's great because it's very close to 1. This is something that we would love to see, so that's awesome that we have a good R-squared value. We look at the significance. This is smaller than 0.05, so our regression model is significant. It cannot be attributed to chance. Now, whenever we go look at our two variables, the percentage of games won and the active alumni, we can see that the percentage of games won, if you have a 1 percentage point increase in the percent of games won, you would have a $38.83 increase in sales. Now, for active alumni, what this means is if you have 1 person increase in the number of active alumni, that you have a 85 cent increase in the amount of sales for that season. But whenever we go look at our p-values, we can see that for the percentage of games won, our p-value is greater than 0.05. So the percentage of games won, the relationship between that and the amount of sales in a given season is non-significant. It can be attributed to chance. However, whenever we look at the number of active alumni, in relationship with the sales. This is significant at the less than 0.05 level, so it cannot be attributed to chance. So we say that there is a significant positive relationship between the number of active alumni and the amount of sales for a given season. So that gives us our really a good understanding of what is to be expected for our regression output, kind of what you should say. So I'll type that here just so you have that. It's really important to understand. So here there is a non-significant relationship between the percentage of games won and the sales for a given season. However, there is a positive and significant relationship between the number of active alumni and the sales for a given season. And so we can put that here. That way we can see it a little bit better. So we have that, and typically we would do a little bit more, but this is the basic understanding that I want you to really understand what the beta values mean, these coefficients. Really we're focused on our x variables here, and I want you to understand the p-values, that we need to look at those, and if they're greater than 0.05, then that means they're non-significant. If they're less than 0.05, then that means they are significant. We also have to look at the significance of our f, because that tells us if the actual model, the overall model, is significant. And of course it is. It's less than 0.05. And then it's also good to look at the r-squared value, because that tells us the variance. This tells us the amount of variance explained by the independent variables. And the more variance explained, the higher predictability of these variables in relation to your y variable. So that's why that's really important there. So I've basically given you the results for this. Now I want to make sure that you really understand this, so if you have any other questions about how to do this or how to interpret these regression models, please email me at kt.manus@ttu.edu. Thank you.